All right, so for today, I'm going to be looking at questions 21 through 24. Homework for today is called Simplify Radicals. Well, a radical, a radical is a symbol that we see in our questions here that looks like almost like a division sign. I know some people call them square roots, but that is the method that we use to find the root of an exponent of 2. Now, this is actually used for any exponent to find the root. So we could call the square root, we could call it a third root, a fourth root, or fifth root, and so on. But the method that we use is this, we use this symbol that we call the radical. So for our assignment, we're going to start calling these radicals. As of now, we have talked about the perfect squares. It's an example. We know the square root of 1 is a whole number, right? The square root of 1 is 1. We know the square root of 4, right? The square root of 4 is 2. We know the square root of 9. We know the square root of 16, square root of 25, square root of 36. These are numbers that give us, the square root of these numbers give us a whole number. But what if I asked you guys the square root of 27? Right? We cannot think of a number that multiplied by itself will give us 27. Right? People can be like, oh, how about 5? Well, 5 times 5 is less than 27. How about 6? Well, 6 times 6 is more than 27. So we cannot think of this number. We can even go over to our calculator, and the calculator is going to give us a decimal. But for today, we're going to be looking at non-perfect squares. Some of them might be perfect, but we're going to be looking at some non-perfect squares. But what we're looking in is into simplifying. Now, simplifying is basically write our radical with smaller numbers. So let's take a look. We'll start with number 21. Number 21, what I'm going to be looking at is I have a whole number, I have a 3 outside, and the square root of 27, right? Radical 27. So what I'm going to do, I'm not going to do anything to my 3. So let me just copy down my 3. I'm not doing anything with the number on the outside. But my square root, my radical 27, I'm going to break this into 2 radicals. So I'm going to be thinking of 2 numbers that multiplied together equals 27. But one of my numbers has to be from the perfect squares. So a reminder, let me just show you guys the list that I have at the side. Again, it has to be one of those perfect squares. Let me erase the square root of 1, right? That one doesn't really make my number smaller. So let me erase the square root of 1. We're not going to use that. So again, I'm thinking 2 numbers, any 2 numbers. They don't have to be the same number. Any 2 numbers that multiplied equals 27, but one of my numbers has to be from that list. Then I start thinking, oh, could it be possibly 4? Can I do 4 times something equals 27? Now, so let me write a 4 there for right now. Like I said, I'm saying, could it possibly 4? Now, if you're not sure, grab your calculator and go 27 divided by 4. If it gives us a decimal, 27 divided by 4 gives us a decimal, then 4 is not a good number. I do try it out, and yep, it does give me a decimal, so I'm going to say no, 4 did not work. How about 9? Can I think of 9 times something equals 27? If you're not sure, grab your calculator and go 27 divided by 9. Well, 27 divided by 9 is 3. So it does give me a whole number. So then I come over and say, oh, yeah, I could have thought 9 times 3. Now, the square root of 9, right? Radical 9 becomes a perfect square. The square root of 9 is 3. So I'm going to cancel that, and I'm going to say this becomes 3. Then I'm going to come over. What I'm going to do, I'm going to multiply. One thing we have to remember, whole numbers with whole numbers can be multiplied. Radicals with radicals can be multiplied, but I cannot mix and match. I see number-wise, like whole numbers, I see this 3 and the 3 that I had on the front to begin with. So I'm going to call this 9. Notice I multiply those. So 9 times radical 3. So I start the way it was at the beginning. I have a number at the front and I have a radical. But my radical now, it's a smaller number. And then I ask myself, can I simplify this even more? Can I simplify radical 3 even more? The way I'm going to simplify, if possible, I'm going to think of two numbers that multiplied equals 3, but one of them has to be from my perfect squares list. Let me zoom out so we remember our perfect squares. Nope, we're not going to be able to find that. So radical 3 is as simple as we can go. Now, if we were doing this on paper, right? 9 radical 3, we can easily write that on paper. The way we're going to be doing this for our assignment, the way we're going to type this, the number at the front, in this case is a 9, we're just going to type in a 9. Now, for radicals, I'm going to use the word radical, but I'm going to abbreviate that as RAD, and I'm going to open and close parentheses. Inside the parentheses, I'm going to write the number that I have inside the radical. So my answer is going to be 9 RAD for radical, open and close parentheses, and inside the parentheses, I have a 3. So this is how my answer will look like, 9 radical 3. All right, let's try this again. Let's take a look at the next question. 5 radical 245. So then I look at the 5. I'm not going to do anything to the whole number, so I'm just going to write my 5. Radical 245. Start thinking, okay, let me break this into 2 radicals, if possible. Let me see if I can do this. But one of them has to be from my perfect squares. And then I think, could I possibly use the 4? Well, 245 divided by 4 gives me a decimal. So nope, I cannot use the 4. Could I possibly use 9? Notice how I'm going down my list. 4, 9, 16, 25, 36. Could I possibly use 9? And 245 divided by 9 gives me a decimal. So nope, 9 does not work. Could I possibly try 16? Now notice I'm trying numbers and some of them don't quite work. This is what you gotta do on your work, on your homework. You gotta keep on trying. Well, square root of 16, 245 divided by 16 gives me a decimal as well. So nope, that one doesn't work. Now, what about 25? Could I possibly do that? Nope, it doesn't work either. How about 36? Nope, doesn't work either. How about 49? Some of you might be saying, I don't see 49 on my list here because I cannot write my whole list. I know after 36, the next perfect square is 49. So I'm thinking 49. Can I possibly use 49? I'll check with my calculator. 245 divided by 49 is 5. So it did give me a whole number. 49 times 5 equals 245. Now, square root of 49, that becomes a whole number, right? Square root of 49 is 7. Remember, I have to multiply my whole numbers. I have a 5 and a 7. 5 times 7 is 35. So I'm going to write this as 35 radical 5. Then I ask myself, can I simplify that radical even more? Nope. No, we cannot. So I'm going to write this as 35 rad, open and close parentheses, and my 5 inside the parentheses. Make sure you type everything all together. No spaces, all together. Let's try a couple more examples. Let's take a look at number 23. 7 radical 192. So I'm not doing anything to the 7. But my radical 192, I'm going to split it into 2. Then I ask myself, can I possibly use the 4? Grab my calculator. 192 divided by 4 is 48. The square root of 4 is 2. When I multiply these numbers, I multiply my whole number, so I get 14 radical 48. But remember, I gotta ask myself, can I possibly simplify this radical even more? For even more, I'm thinking two numbers that multiply equals 48, but one of them is a perfect square. And yeah, I could think 4 times 12, right? So again, I have my 14 on the front. Yeah, 4 times 12 is 48. The square root of 4 is 2. When I multiply my whole numbers, I get 28 radical 12. Just because I simplify once doesn't mean I'm done. I gotta ask myself always, can I simplify this even more? Now, radical 12. Okay, can I simplify this even more? Right, I'm gonna leave my 28 outside. Can I think of two numbers multiplied equals 12, one of them being a perfect square? And we're gonna be like, yeah, 4 times 3. The square root of 4 is 2. When I multiply my whole numbers, I'm gonna get 56 radical 3. Right, 28 times 2 gave me 56. Now I gotta ask myself, can I simplify that radical even more? Nope. So my answer is gonna be 56 radical 3. Now in blue, let me write this in blue. Somebody might be like, do I really have to take that many steps? No, not quite. I could have just started. Let me do the work here at the side. Let's say I had 7 radical 192 to begin with. Do nothing with my 7. But my radical 192, I split that as 64 times 3. 64 times 3 is 192. The square root of 64 is 8. When I multiply my whole numbers, gives me 56 radical 3. If I'm able to break my radical into two radicals, and one of my radicals is perfect squared, it is easier for me, or it's faster for me. The bigger the radical, the faster I'll get to the answer. Notice how we started with radical 4, perfect square root of 4. But what if we start with this perfect square root of 64? The bigger the radical, the faster we get to the answer. Doesn't matter how fast we get to it, as long as we get to the correct answer. Okay, let's take a look at number 24. So I'm not doing anything to my -3 on the outside, but 448, I'm going to break this into two radicals. Can be like, oh, what if I go 4? Well, this gives me 112, right? 4 times 112 is 448. My square root of 4 becomes 2. When I multiply my whole numbers, -3 times 2, I have -6 radical 112. Then I'm like, well, I'm not going to do anything to my -6. I'm going to try to break my radical even faster. I could probably divide this by 4. But what if I divide it by 16? Right, a bigger perfect square. Yep, 112 divided by 16 gives me 7. So that means that 16 times 7 is 112. The square root of 16 is 4. When I multiply my whole numbers, -6 times 4 gives me -24 radical 7. Again, the bigger the perfect square, the faster I get to my answer. So my answer is -24 radical 7, because radical 7 cannot be simplified even more. So I'm just going to go -24 RAD for radical, open and close parentheses, and inside my parentheses, I put a 7. Altogether, no spaces. So let me zoom out. That's what we did today.